Hello everyone, welcome to another one of my PowerBox series of videos. In this video we're going to be looking at turbine telemetry, and in particular we're going to be setting a flameout warning for our turbines. So pictured in front of us, I've got an old Jetcat P160 here. It's got very low hours on this particular unit. What we're going to do is, I'm not going to fire it up in my garage because I'm indoors. However, we're going to actually use the turbine telemetry, and to simulate the exhaust gas temperature, I'm going to use a heat gun. So I've got my trusty old Bosch heat gun here, and what we're going to do is actually heat up the sensor, which is actually on the inside of the tail cone. So basically during the video when we're looking at the exhaust gas temperature, I can actually heat up the sensor by placing my heat gun inside the exhaust nozzle. So we can simulate an increase in exhaust gas temperature. And the other thing that we're going to be looking at is our fuel pump voltage, again via the telemetry. However, again, because I'm not actually running the turbine, we're going to be using a power supply. I've got a little Hewlett-Packard lab power supply which I'm going to be using to simulate the pump voltage as far as the core radio is concerned. Okay, without further ado, I'll shift over to the core's LCD screen. Okay, we're back this time looking at the core's LCD screen. You'll notice all the telemetry widgets are flashing at this point in time. It's only because I've switched off the turbine and my receiver, so it's just an indication that there's no telemetry being received by the transmitter. Just talking about telemetry flameout alarms, a lot of people in the past have possibly used RPM as a trigger for their flameout warning. I'm not a big fan of that because on some of the bigger turbines it can take some time for the turbine to ramp down, especially if you're at full throttle and you have a flameout. Can take a long time, a couple of seconds for the RPM to drop. So a better variable to look at is actually the pump voltage. The pump voltage is pretty much instantaneous because that's controlled by the ECU. The ECU will detect the flameout pretty quickly, and it'll switch off the pump basically and drive the voltage to zero for most systems. So we can use that as a trigger. So we can't just use the pump voltage because obviously, when you go to start your model, if you just use the pump voltage, the alarm will go off because before you start your turbine you'll have 0 volts on your fuel pump. So it's not much use on its own. So this is why we need exhaust gas temperature as well. So if we use the EGT, we can actually compare the two. So we can look at the EGT and say, hey, is the engine sort of hot? If the exhaust is hot or the engine is hot, therefore the engine's obviously been running, and we can use that as a trigger. So in conjunction with a fuel pump voltage of 0 volts and an exhaust gas temperature of say above 250 or 200 degrees Celsius, we have a pretty good indication that something's gone wrong and the engine's stopped. So if you're flying around and the engine just dies, your exhaust gas temperature takes some time to come down. So during that phase, the ECU will actually ramp the pump voltage to 0 pretty much straight away. However, the exhaust gas temperature can only come down slowly, and therefore we can trigger on those two inputs and basically generate our audio flameout warning. And that's what we're going to do today. Alright, let me switch on my receiver and the telemetry, the turbine, etc. Just wait a few seconds for it to all initialize. There we go. And you'll notice my screen, I've got a separate widget for RPM of the turbine, which we're not really interested in today. We've got the exhaust gas temperature, or EGT. We've got the turbine pump voltage. Now don't forget, this pump voltage is being generated from my little power supply. So I can vary the knob on my power supply and you can see that go up and down. So yeah. So we'll play around with the pump voltage. So I'm not actually using the pump voltage from the ECU. I'm just using a voltage sensor, and I've labelled the sensor turbine pump. So that's one good thing with the core. You can rename all the sensors to whatever you like. So as far as we're concerned, it's basically the pump voltage. And the logic and all that, the telemetry controls will all be applicable to even if we were using the proper ECU pump voltage. And the reason I'm not using the ECU pump voltage is I'm not going to fire up my turbine in my garage because I'll go deaf and etc and annoy the neighbours. These two larger widgets here, they're just basically the status screens off the Jetcat ECU. So basically I've got a GSU plugged in so I can actually scroll through certain values and you see those update in real time on the screen, like min-max. They're all my min-max runs, and because I haven't run it yet it's not going to show anything. If I go back to the normal run menu, it shows us temperature in Celsius, RPM, the voltage, that's the battery connected to the ECU, and like a little status screen, so it basically indicates what the turbine's doing at any particular time. I've got another status screen here at the moment indicating the turbine's off, which it is. I've got a turbine throttle indication, so that's from the ECU, so that's actually the ECU's reading. And then I've got one from my actual core radio itself, so this is my actual throttle stick position. So for instance, if I vary the trim, so that's half trim and then that's full trim, and you can probably hear the ECU in the background beeping, so it's ready for ignition. Just switch it down, and then obviously if I move my throttle stick, you'll notice the throttle percentage in the left hand box is the core's throttle output, and the one on the right is actually the output from the ECU. So at around about mid stick, which is 0% on my core roughly, it's about 52% on the ECU, so that's pretty much correct. Okay, so let's have a look at the telemetry to set up our flameout warning. So what do we need? We're going to be looking at pump voltage and exhaust gas temperature. So there are two variables. So let's go into the telemetry controls. And we've got nothing set up at the moment. So let's make one for the pump voltage. So this is where we select the source for our telemetry. So you notice there are two turbine entries here. So the bottom one from memory is the actual ECU, the Jetcat ECU going through the Vspeak converter. I'm using a Vspeak converter for the basically the translation of the ECU values from the old ECU, Jetcat ECU. So you notice we've got RPM, exhaust gas temperature, which is the one we're interested in, throttle, pump, fuel. So normally I'd select pump in here, but because I'm not actually using the actual turbine, not turning it on, we're not going to have a pump voltage from the ECU, but we're going to have another turbine here. So this is my voltage sensor connected to my power supply. So we're going to use the pump voltage from that. So let's do that. And let's rename this. Let's call this a, I don't know, a pump volts. That'll do. And you'll notice at the moment it's got an input of 0, but if I fiddle the power supply, the voltage goes up and down as we expect. Let's program it to what we want. So I did cover this telemetry control in a previous video, so you might want to go have a look at that. That's the one that has the telemetry plus repeating audio or audio repeating video. The turbine pump voltage for most turbines you'll find will be fairly low, like, you know, it'll be like maybe 0.3, 0.2 volts at idle, and then it'll ramp up as well depending on the fuel flow required by the turbine and your throttle setting, obviously. So for instance, in this case we want to detect a 0 volts or something below the idle voltage. So it's probably a good idea to make a mental note of what your idle voltage is on your pump and set this telemetry control to a little bit below that. So this power supply can only wind it down to about 0.25 volts before it jumps to 0. So let's go to 0.25 and we'll use that as our trigger. So to make it into like a trigger with very low hysteresis, we went a bit too far. Let's set that to 0.25 and this one we'll set to 0.24. And you'll notice what happens now is if we go below 0.25, the output from this control swings to negative 100%. So you can imagine this is a servo swinging to minus 100% servo travel. And if we go above 0.25, it swings to plus 100%. So basically full travel in the opposite direction if it was a servo. So what we're doing now is basically if the pump is off, we've got negative 100%, pump is on, we've got 100%. So this will stay 100% whenever the pump is running. So whether it's running at idle or basically flat out, this will just stay at 100%. However, we want to detect when the pump is off. So what we're going to do to keep the logic simple is invert the logic in this particular telemetry control. So at the moment, if I increase the pump voltage, this goes to positive 100. If I decrease it, it goes to negative 100. We want it to operate in the opposite direction. So if I hit the inverse box and convert that to, or modify it to inverted, it gives us an inverted output. So now when the pump is off or at 0 volts, we get positive 100%. And then obviously when we turn the pump on, or if the ECU turns the pump on, it goes to negative 100%. So we wanted to check the condition where the pump is off. So that's why I want it to be positive at this point in time. And you'll see why later when we use the virtual switches and use some logic. So that's the pump voltage. So again, with 0 volts, pump off, the output is positive 100. If the pump switches on, the output goes to negative 100. Simple as that. Okay, exhaust gas temperature. Let's do one for the exhaust gas. So in this particular case, I'll go straight to the ECU and look at EGT. So this is coming directly from the Jetcat ECU via the Vspeak converter. And at the moment the sensor's reading about 26 degrees C. It's nice and comfy in my garage. Let's rename this to say EGT, exhaust gas temperature. So it makes sense a bit later on. And same thing here. Now, if we were running, if we were programming this up for a real turbine, I would set this value around maybe 200 degrees or 150, somewhere in there, because you want to detect when the engine's hot, basically. So you don't really want our alarm going off when the engine's cold. So when you're spooling up or starting, you don't want a flameout warning. So a lot of guys use something around 200 or 250. You can play around with this value to suit your liking. You don't want to set it too high. Like obviously you don't want to set it to say 500 or 600 degrees C, because when you do get a flame out, the exhaust gas temperature sensor will actually cool down, but it takes a lot of time to go from say 650 degrees C all the way down to 200 versus going from 650 to say 500. So just keep that in mind. Now for this particular example, I'm not going to heat the sensor up to 600 odd degrees C, because it would just be wasting our time. And the other thing is, because the turbine's actually going to be activated, the ECU is actually functional, what will happen is if the temperature gets to above 100 degrees C, the turbine will kick into its cooling phase and it'll switch on its fan, or motor I should say, which then rotates the turbine and it'll try and cool the sensor down. So bearing that in mind, we're going to choose a more realistic value of say 75 degrees C for this example. At the end of the day, it's the same thing, whether we use 600 degrees C or 75 for this particular example. And this one we're going to set to 74, because basically I want it to snap over, so I don't want any sort of intermediate value. And you'll see at the moment, with the engine being cold, it's currently at 26 degrees C in this little light blue box. That gives us the real-time value. Basically, when it gets to 74 degrees or anything above 74, it'll snap over to 75, and this value will go to positive 100%. And just to prove that, I'm just going to grab my heat gun, turn on my heat gun, wait for it to heat up a little bit. You can probably hear it in the background. Now I'm just going to apply it to the exhaust gas sensor, or temperature sensor, or thermocouple. And you'll notice as soon as we get above 75, it's gone to positive 100%. If I take the heat gun away, it drops down to minus 100. So let's apply it again, heat it up. So you can imagine we're running a hot turbine now. The turbine's running. This has gone to positive 100% travel. If I remove the heat, once it gets below 75, there it goes to minus 100. So that's going to be our trigger for this particular example. But, you know, like I said, in a real life scenario, you'd set these limits up around about, 200 degrees, somewhere around there is probably a good value to play with to start with. So that'll basically give you plenty of time where the audible warning will go off. You know, we've got telemetry, flameout, or flameout warning, or whatever you want to call it. And that'll give you plenty of heads up insofar as the warning's concerned. And then if the engine's cold, you know, when you first turn on your model for your next flight, obviously the turbine's going to be below 200 degrees C at that stage. You're not going to get an audible flameout warning. So hopefully you're following that so far. So we've got the two telemetry controls, just to reiterate. So we've got one for the exhaust gas temperature and one for the pump. Easy as. So now we need to compare the two, and basically we'll use a virtual switch to do this, and we'll use the AND function. So basically we want an output to go high, for instance, which will trigger our audio later on. I'll show you how to do that. When the exhaust gas temperature is above our preset limit, but the pump is below the normal operating voltage. So in this case, say 0 volts, or below 0.25 volts that I'd set. So let's go to our virtual switches. So virtual switches are really handy. I'll cover virtual switches in another video because some people get hung up on this. Not so much on the switching action, but more so on the logic. Because if you don't have an electronics background or a mathematical background, you may have not come across logic operands like this. So you've got like OR function, you've got exclusive OR. This is a core and atom custom one called lock RS and lock SR, and they I'll have to show you in another video in another day, but they allow you to have like a lock where the throttle stick, for instance, must be returned, say, below a certain point before the switch will trigger to another state. It's good for safety throttle, like a safety switch. And then we have the AND function, which is what we're going to use for our two controls today. So first of all, let's give our switch a proper name. So we can call it Flameout, but I'm not going to call it Flameout because we're going to need another logic switch, and I'll explain why in a bit later. So we'll call this one, say, Turbine. I'm just trying to think, I should have thought about this, eh? Turbine state or something. Because this will be an intermediate logic switch, and you'll see why in a few more minutes. Okay, so remember we've got the two telemetry controls we want to use. So again, with a logic switch, you can use a physical switch, or you can use one of the rotary dials or the linear sliders on the side. You can use another virtual switch to feed into a virtual switch to make fairly complex setups. But in this case, we're just going to use telemetry. So we'll select, say, pump volts for the first option. And you'll notice here we have an option to basically set our pump voltage trigger as well. Now remember, we inverted it in the telemetry control menu. We could do it here as well, because you can basically slide these sliders around and basically slide the, in effect, invert the logic. But I'll just leave it as it is. Now notice the red's not coming up on my video camera too well on this screen for some reason. It just doesn't like it. My sensor, CMOS sensor in my camera doesn't like it. But there's the red bar, then you've got a small yellow bar between the two percentage values, and then you've got the green. So the yellow section is a hysteresis zone, and I'll probably explain that in another video. So if you have a close look, there's a little white cursor on the far right hand side. So at the moment the pump voltage is low, so the output is on, if you like. If I if I rotate the knob on my power supply and increase the pump voltage, you notice the cursor has now moved over to the red zone and the output is effectively off. And if I reduce the voltage again, it goes back into the green. So let's have a look at the function on the pump volt. So increase the voltage. So let's say the pump is running. So the pump is running and our logic says that it's actually off. If the pump is switched off by the ECU, we get a non-condition. Okay, and notice the output hasn't changed because basically the bottom input, there's nothing defined yet and it's in the off state. So this output will only go on if both of these are on. So our second variable is going to be our exhaust gas temperature, EGT. Select that. Now you notice it's currently off because the turbine is cool, so it's in the red zone. Again, the red's not coming up very well on the screen, but believe me, it's red. So if I grab my heat gun, turn it on again, just wait a few seconds for my heat gun to actually heat up. Now I'll apply the hot air to the sensor and give it a few seconds to heat up. And you notice the little white cursor has moved over to the green, indicating a hot condition. If I remove the heat gun, it's basically gone back into the red. Apply it again, it's on. Remove it after a few seconds, it cools down. And there it goes. So if we have a look at the actual state now, so at the moment, so imagine with the turbine, or say you've just turned your model on, this is the state that you'll have. You'll have a pump at 0 volts, so the turbine's not running, so the pump's at 0 volts, the exhaust gas is cool, or the exhaust outlet is cold, so that's off, the sensor's off. So when we end these two, an on and off produces an off state. So basically this will feed into our audio trigger, and that's currently off, so there's no audio or no alarm at this point in time. Now, say you fire up the model and the pump comes on, and then the turbine spools up, heats up. So again, I'll turn my trusty heat gun on. Wait a few seconds. Takes a few seconds for my heat gun to heat up, and I apply it to the sensor. And it's about, I'm just reading the temperature on the, it helps if I turn my heat gun on to the proper setting. So there you go. And actually I've just overheated it a bit, and the turbine just went into its cooling phase, but I'll just try and keep it between 75 and 100 degrees C. About there. So at the moment, you can imagine that's your turbine running. So turbine's running, you notice the output is still off. However, now we have a flame out, so now I'm going to turn the pump voltage to 0. I'll do that right now, and you'll notice we've still got a hot exhaust, so the output is on, and that'll trigger our audio alarm now, and that'll say, you know, turbine alarm or turbine flame out or whatever. And then if I remove my heat gun, it'll slowly cool down and it'll switch to off again. So we need to set up the audio. So all we need to do is just go into our voice settings menu, and you'll notice the default entry for flight modes. This is where we're going to set up our audio. So let's make it just text. So select text, which is the default setting. Now, what do we want to say? Do we want to say warning flame out or flame out turbine? Or, I mean, you can put whatever you like in here. Obviously you don't want a message that's too long, I suppose. Let's put turbine flame out. See what it sounds like. Okay, we can quickly test that audio.
Turbine flame out.
I don't really like this guy's voice, so I'll select Ryan.
Turbine Flameout.
I prefer that voice. So again,
Turbine Flameout.
that's what it's going to sound like. The control we're going to use is going to be that virtual switch we set up, so the output of that virtual switch. So remember, if I go into the virtual switches, just to refresh your memory, this virtual switch logic is called turbine state. So back into voice settings, let's set the control for the virtual switch turbine state. And at the moment it's off because the turbine's cold, pump is off. And the other thing, you want it to repeat, so go into here, select time interval, and I might make it every 2 seconds because we want it to be a critical, repeating warning type thing. And let's go back to the main screen. So you notice the sensor's at 45 degrees C, pump voltage is off 0. So I'll just fire up the heat gun again. And you'll watch the exhaust gas temperature as that starts to increase. And what I'll do, I'll simulate a flight. So basically, you're going to start your turbine now. Pump voltage will start to increase. Say it's, say it's idle at 0.2 or whatever volts, or 0.3, say. Doesn't really matter in this particular case. Let's heat up the exhaust gas sensor to simulate a hot exhaust. I'm just got to make sure I don't go over 100, otherwise the turbine will go into its cool down phase because it doesn't know it's running, so to speak. We're just simulating it. So we're flying around, exhaust gas temperature's up nice and hot, and then the ECU detects a flameout, say. So what it'll do is it'll drop the voltage down to 0.
Turbine Flameout.
And you'll notice the audio's going off.
Turbine Flameout.
And the exhaust gas temperature will slowly come down to our trigger point.
Turbine Flameout.
So if we go below, in this case, 75 degrees, it goes off. Now, this is all very well. So you think, oh, that's it. That's all we need to do. However, there's one configuration where it'll catch you out. And that's where you've come in, you've landed, and you might be taxiing on the runway, and you pull up and you turn off your turbine from your radio. What will happen is the pump voltage will go to 0, but the exhaust gas temperature might still be quite hot, say above 200 degrees C, might be 400 or 300. And you don't really want the audio going off, while you're, going to retrieve your model. It's a bit annoying. So we can fix that pretty easily. So this is where we need a second virtual switch, basically. So we go into our virtual switches again. Actually, what I'll do, we'll do it here because I have to change the audio setting as well. So this particular switch, we're going to call our Flameout switch because this is the actual output we're going to use for the audio. Flameout. It's a bit hard typing here with the tripod in the way. Oops. Okay. So what we're going to use an input for this particular switch is we're going to use the output of turbine state. So in other words, when that's on, we're going to use that. So we can say turbine state and basically go into virtual switch, turbine state. Okay. So basically when this goes on, this output here will be on. And we're going to actually use a switch. So for instance, a lot of the jet pilots will use their particular safety switch for their throttle kill. So what we're going to do is we're only going to activate this audible alarm when we're in the run mode of the switch. So basically if you kill your turbine, if you come and land and you kill your turbine, the pump voltage will go to 0 volts, the exhaust gas temperature will still be high. However, because we're going to detect the condition of the switch, we're basically not going to enable it in the off state of the switch. So when the kill switch is on in effect, or the model shut down, you won't get the audible flameout warning. It'll only be activated when the switch is in the run position, or turbine run position. So simple as that. So all we need to do for that is compare the turbine state with the switch position. So it's pretty simple to do. I'm sure most of you have done this before. So we select our switch. So I'll just use this switch in the picture here, switch J. And we can set well, where we want to have it activated and where we don't want to have it activated. So in this particular case, we want the switch activated, say when I'm pulling it towards myself. Say that might be my normal turbine run mode. So if I just invert the logic here using the switch, actually I'll move these down a bit so the red zone encompasses the middle position of the switch. So basically that's my turbine off, say 2 off positions. This is a 3-position switch. So my turbine run state is when this is all the way facing me. So now we'll get, with the switch in the run position, you'll have an on condition here in this box, and then the turbine state we proved in previously when the pump's not on, it's at 0 volts, exhaust gas temperature is high, this will be on, and then we just AND these two together as well, like that. And instead of using the top one for the audio, to trigger the audio, we're going to use the bottom virtual switch to trigger the audio, the one called Flameout. So let's try it. We still have to go back into the audio screen, don't we? Okay, so back in our audio voice settings menu, you can see at the moment we still have the old virtual switch here, turbine state. So we're going to change this to the newly set up virtual switch called Flameout. So hopefully this will all work. I'm sure it will. And let's go back to the home screen and let's simulate a flight. Okay. Temperature of the sensor is about 50 degrees C, so it's a little bit warm. It's below our threshold, so this is basically a cold turbine at this point in time as far as we're concerned. So let's fire up our turbine. So we activate our safety switch to the run mode, or whatever you like to call it. So all the turbine electronics are now enabled, and you can go through the throttle up procedure or whatever. The power supply voltage will be up high, so say 0.25 volts. However, our temperature at the moment is cold. Remember, our trigger point's 75 degrees C, and of course, in real life it'd be set to around 200 or so. So I'm just going to fire up my heat gun. Let's warm up the exhaust gas temperature sensor to indicate a running turbine. So we're above 75 degrees C now, so I'll try and keep it around 80, 90 degrees C. So you take off, you start flying, might go up a little bit more, 90, whatever, you're flying around. Now let's simulate a flameout again, to make sure it all works still. So I'll keep the temperature up high, but the pump voltage drops.
Turbine flame out. Turbine flame out.
There you go.
Turbine flame out. Turbine flame out.
Oops, I went a bit too hot.
Turbine
Triggered.
flame out. Turbine flame out.
I just triggered the turbine's cooling system, so let me reset that again. I went a bit too hot. So I'll turn the pump voltage back on again. Oops. So we're at about 80 degrees C. And now we're going to come in for a landing. So we're flying around, everything looks normal. Pump voltage is high, above our threshold. Could be even higher. And then you come in and you want to kill your turbine. So what you will do is you bring your throttle stick back to idle. And then you might flick your turbine kill switch to kill. So that'll kill the turbine. So that'll drop the fuel pump voltage to 0. You notice the exhaust gas temperature is still high, but we don't get an audio alert now. So you can just now let your turbine go into its cooling phase and it'll cool down by itself. And you won't have any audible alert, any flame out warning going off annoying you. Simple as that. Well, hopefully you found this video valuable, and it's just mainly to help out core and atom users in some of the slightly more complex programming, although it's reasonably simple when you think about it. I'll try and cover off some other examples in some later videos as well, which cover off a bit more complicated setups. Thanks for your time.